Hello, Coach Travis here with another calculus problem. And so this is a problem about concavity. So we've got a function, s of x is equal to x cubed minus 9x squared plus 8x minus 7. And we want to know if the graph of this function is concave up or concave down when x is equal to 5. So this is probably, this is a relatively complicated function. I don't have much, off the top of my head, I don't have much of an idea of what the graph of this function looks like. So you might think, oh, well, how are we supposed to answer this question? And the key is understanding the relationship between the derivative, or in this case, the second derivative, and concavity. And so the thing that you have to remember is right down here, that the original function is going to be concave up whenever the second derivative is a positive number. And on the other hand, the original function will be concave down whenever the second derivative is a negative number. So it's all about looking at the sign of the second derivative. If the sign of the second derivative is positive, that means the original function is concave up. If the sign of the second derivative is negative, then that means that the original function is concave down. So that actually, if you understand that, then this problem is not too big of a deal, because I would just, to answer this question, what I would do, now I've done it, what I would do is I would find the second derivative. So let's see, so the first derivative is 3x squared minus 18x plus 8. And then I need the second derivative for this concavity test. So now I'll find the second derivative. So the second derivative is equal to 6x minus 18. And then now I want to know what happens when x is equal to 5. So I'm going to put 5 into this function. So let's see. So s double prime of 5. And again, I'm putting the 5 into the second derivative. I'm not putting 5 into the original function because it's the second derivative that's giving me the information. So I need to put that number 5 into the second derivative. So s double prime of 5 is whatever it is. It's going to be equal to 30 minus 18, which is equal to 12. And that is a positive number. And so the fact that this is a positive, so we're a positive, and so that tells me that we should be concave up. So this function, I claim that the graph of the original. Okay, so again, the graph. I don't know what well, actually, I do know what the graph of the second derivative looks like, but I don't care. I don't care what the graph of the second derivative looks like. All I care is whether the second derivative is a positive number or a negative number. And we found that it is a positive number, and therefore the original function will be concave up. So the correct answer to this question is concave up. And like I said, it's always satisfying to me to draw a graph and check that I was actually right. So I think I've got a graph that I can show you here as soon as I clear off the board. So here is, there's the graph of the function. And as you can see, there's our point. There's our point where x is equal to 5. And right there at that point, it kind of looks like the function is smiling. That function is concave up. right? At that point right there, the function is smiling, and that means concave up.